Alrighty. We are headed back here to 8.2. You might be thinking, what are you doing? We've already done 8.2. Kind of. There was two parts to it, and we already covered the parts on solving, but not so much on graphing. So what I'll just do with this, we're just going to take one day to go back to 8.2, and I'll just mark it here that we're going back to look at the sine and the cosine curves. We're not going to focus at all on solving. We've already worked on that extensively. Instead, I just want to talk about graphing. The sine and the cosine curves, real quick here, domain and range. Never a bad idea to be talking about domain and range with any function. Every angle has a sine or a cosine value. So I'll say x is an element of the real numbers. That's a way of saying our domain and range for the sine and cosine curves can be anything. The range is a very different story. There's a very specific interval of values, -1 to 1, that sine and cosine values can be. So now as we're looking at jumping to the graphs here, how do we get a good sense of what the sine and the cosine curves look like? Well, what we do is we look at some quadrant points. So I'm going to work in radians the whole lesson. But if I looked at 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi, which is essentially taking the unit circle and breaking it down into fourths. Okay? These are some good points to look at. I'm going to blow this up here a little bit because all I really want to do is focus on this bottom half. Those points are the easiest ones to deal with, and we do that a lot of times when we graph. When we're plotting points, we don't necessarily want to deal with really tricky, complicated numbers. We want to make it as easy as possible. Okay? So now if we were to go to the unit circle and just think about the coordinates, remember for any given point on the unit circle, that angle's sine value is the y-coordinate and the cosine value is the x-coordinate. Well, if you were to verify this, and it's not a bad idea right now through your to dig in your notes and grab a copy of the unit circle so you can verify these, not just take my word for it. At 0 radians, the y-coordinate is 0. At pi over 2, the y-coordinate is 1. At pi, it is 0. At 3 pi over 2, it's -1. And at 2 pi, it's 0. That's enough. To be quite honest here, that's enough to get a pretty good look at a sine curve. Okay, we don't need to plot all, these 5 points will give us a decent idea what the shape looks like. We don't have to look at a million points. So the point 0, 0 would be right there. And again, at pi over 2, we said it heads up to 1. At pi, it's 0. 3 pi over 2, it's -1. And at 2 pi, it's 0. Now, if I were to connect all those points here with just one continuous curve, we get something that looks like that, and that is one period, okay, because these functions repeat. That's why they are called periodic functions. That is one period of the sine curve. Cosine follows a lot of really, really similar properties, except we're looking at the x-coordinate, and basically what we see here is cosine, instead of starting at 0, just starts up at 1. At pi over 2, cosine is 0. At pi radians, it is -1. 3 pi over 2, it is 0. And at 2 pi, cosine is back to 1. All right, so we're going to see the same thing here in the sense of a curve that is periodic. I'll put this one in red. except it starts up there. At pi over 2 it hits 0, bottoms out at pi, 3 pi over 2 back to 0, and at 2 pi it hits its max once again. Leading to a graph that looks something like that. Okay? At any point in time in 8.2 and 8.3 that you hear me refer to parent functions, I'm talking about the sine and the cosine curve, because to do the other things that we will do graphically, it helps to refer back to these two functions. So we will do that quite a bit. So here's the first two things that we want to do here is be able to kind of stretch the function. When we talk about amplitude, what we're really getting at is taking the graph and stretching it vertically. And when we change the period, that's the amount of time that it takes the graph to repeat. It's typically 2 pi radians, like we saw on those first two examples, if the period of the function hasn't been changed. We can change it, and in the next two examples we will. Another way of thinking about that is a horizontal stretch. So we saw in that first example that sine and cosine repeat every 2 pi radians, and they fluctuate between -1 and 1. Well, the whole point of periodic functions is to model data that repeats, okay, that follows patterns. Well, that doesn't, those functions don't do us a lot of good if we can't kind of change the graph to fit the data that we have. So we got to be able to stretch it out. We may want to shrink it, lengthen it, all kinds of things. That's what we're going to be doing here. A stretches it out vertically, and this is an important one. Remember here, B, which we'll see in the function, that's not the period, but it changes it. 2 pi over B adjusts the period length. Best way to talk about amplitude and period is in the context of an example. So let's look at one here. We've got 4 sine of 3x. Okay. First off, amplitude is 4, which means vertically this graph has been stretched out by a factor of 4. The period, don't you dare say it's 3. Okay, it's the most common mistake that students make with these functions. Don't you dare say that it's 3. It's very much related to it. It's 2 pi divided by 3. If that's confusing, refer back to that previous page of notes where that's what we talked about. Is 2 pi over b tells us the period. Okay? And I'm going to go back and do the original sine of x. That's what we're referring to when we say original. That started at 0. Then we looked at pi over 2. We looked at pi. We looked at 3 pi over 2 and 2 pi. Okay? And sine always starts in the middle. Then goes up to 1, back to 0, down to -1, back to 0. Hopefully you're thinking that graph looks really familiar. It should. It's the sine graph, and in fact, I'm going to plot it again on here in black. There's the sine curve. Okay? Now let's check out the new one, which I will do in red. Okay? This graph doesn't have an amplitude of 1 and a period of 2 pi. It has been changed. Its amplitude is 4. It's been stretched out vertically. And it's been the period of the graph has been reduced. It's repeating faster and faster. All right? So here's the deal. This value for b, remember that's the horizontal stretch. And what it did is it divided the period length by a factor of 3. So to get some x values that are going to be nice to graph, I am going to take all of the 5x values that I had, and I'm going to do the same thing I did to the period. I'm going to divide them all by 3. 0 divided by 3 is 0. Okay, don't be afraid to write out some of these. I'll show you one for an example here. The next one I got to take pi over 2 and divided by 3. I would do pi over 2 times a third, which would be pi over 6. That would tell me that would be a nice x value to plot. Pi over 3 is just pi over 3. 3 pi over 2 divided by 3, that ends up being pi over 2. You do something very similar to that if you wanted to verify it. And we'd finish at 2 pi over 3, which is where the first period should come to a close. Okay, so those are going to be good x values. Now, the graph has been stretched by a factor of 4, so if I want to get the new y values, I should take all of those, multiply them by 4. 0, 4, 0, negative 4, and 0, and now I have 5 points that will show me the shape of the first period of this new graph 4 sine 3x. Okay, let's take a peek as to what this will look like. I can plot these points exactly because notice here that here's pi, and this graph is dividing pi. I'm going to kind of zoom in on it here. It's dividing pi into 6 units. Well, my x values are in increments of pi over 6, so that's great. That's exactly what I'm doing. Okay. Started at 0, 0, and then we said that at pi over 6, it went all the way up to 4. At pi over 3, it was back to 0, down to negative 4 at pi over 2, and at 2 pi over 3, it was back to 0. So we would get a sine curve looking something like that. Okay? There's one period. Now we could certainly continue. Remember, these functions are periodic. That means that they repeat. Okay? Here would be the second period of the graph. Remember we said that 3 in front of the x, what it really meant is this graph repeats more frequently. And in fact, you can see where the original graph did one period, notice how many this one does. Surprise, surprise. It does 3. That's actually what b tells us is the number of periods it does in 2 pi. But there's a good look at 4 sine of 3x. Let's do one more. Okay, cosine graph, amplitude of 2, period is 2 pi over 2, which is pi. So this graph has not, let's see, its period hasn't been divided by 3, it's been cut in half. Okay, so quickly here, let's get cosine of x. I do want to look at its original. Remember, the only difference is that it starts at the max instead of in the middle. Okay? So with cosine, we'll start here, then it goes to 0, down to negative 1, back to 0, and back up to 1. Okay? There's the cosine curve. Okay, now we're going to do the same thing with this new one that we did before. I got to find 5 points that give me the basic, kind of a basic picture of the first period of its graph. All right, I do the exact same thing. This 2 changed the period. We took 2 pi over 2 to get that new period of pi. So again, for the x values, I divide all of them by 2. Remember in the first example, I divided them all by 3. That means I've got 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay? This has an amplitude of 2. It's been stretched, and we haven't really talked about this negative sign and what that does. But we'll include it, and we'll multiply all the y values by negative 2. And this changes the sign for many of the y values. But it gives me 5 points that I can start to use to make this graph. Okay, so let's take a look at what the graph of negative 2 cosine of 2x would look like. Now I got to be a little bit more careful as I plot the points because my new table has increments of pi over 4, not pi over 6. So I got to be a little careful. It starts down here, okay, down at negative 2, and it comes back there at pi, and it hit its max of 2 at pi over 2, okay? And it hits 0 at pi over 4, but what I'm going to do here is just put those halfway in between the first two, even though they don't land on one of the spots perfectly. That's okay. So it started down at the bottom, hit the top, and comes back down, okay? It's been stretched, it's been flipped, and its period has been cut in half, okay? I could do the exact same thing here and just repeat that pattern again and draw that second period. And there we go. Okay, been stretched out. And when we say stretched out here, as far as the amplitude goes, what I'm really referring to here is notice that instead of going between negative 1 and 1, which cosine of x does, this graph goes between negative 2 and 2. That's what that 2 out front did. All right? Oh, we'll call it quits there. That's a pretty good look. What we're going to do next in 8.3 is practice this more, but then we're going to learn how to shift the graph. Okay? Remember, what we did today, we would describe this as stretching. We stretched these graphs vertically. We stretched them horizontally. We want to talk about the concept of shifting next. All right? If you have any questions on this stuff, let's talk more, and we'll see you in class.